Hi, in this video, we are going to discuss about the informed search methods. Informed search methods in artificial intelligence is a type of search algorithm that is going to use the additional information to guide the search process, allowing for more efficient problem solving compared to uninformed search algorithms. This information can be in the form of heuristics, estimates of cost, or other relevant data to prioritize which states to expand and explore. These are the three informed search methods we will be discussing. Number one, generate and test, best first search, and A-star algorithm. Generate and test. This search method is otherwise called as British Museum method. The first step in the search method is to generate one or more candidate solutions randomly, systematically, or using some predefined rules. Once those candidate solutions are generated, we need to test each of the generated solution and check whether it is satisfying the problem's constraints or criteria. Once the candidate solutions are generated, we have to check for the valid solution. If a solution is passing all the tests, then that is considered to be the valid solution. The next step is to check whether we have found the valid solution or not. In case if a valid solution is found, we need to end the process and return the solution. In case there is no valid solution, we will return to the first step and start generating new candidate solutions. We define a termination condition such as reaching a maximum number of iterations or exhausting available resources. If the termination condition is met without finding a valid solution, then we will terminate the process and indicate that no solution exists. And number two is best first search, which is a combination of depth first and breadth first search. This helps us to switch between the paths, and here the most promising node is selected. There are two lists of nodes here. One is open list and the other one is closed list. In open list, there is a list of nodes that have been generated and on whom the heuristic function has already been applied. Then is the closed list, which is containing the nodes that have already been examined. In the best first search, the first step is to begin with the initialization. We will start with an initial node. Often it is going to be the starting point of the search problem. We will add it to the open list. The second step is we have to repeat while the open list is not empty. That is, we have to select the best node from the open list. According to some heuristic function, we will remove it from the open list. In case if the selected node is the goal node, then the search process is complete and the solution is found. In case if the selected node is not the goal node, we will have to expand the selected node by generating its successors, the child nodes. Then start evaluating each of the successor node using the heuristic function and add them to the open list. This second step has to be repeated until the goal node is found, the open list becomes empty, indicating that no solution exists. Now let us see an example for the best first search. Here node 1 is the root node and node 8 is the destination node, goal node. And there is a heuristic table which is given and the hypothetical H value for each of the nodes. Hypothetical H value represents the straight line distance from the particular state to reach the goal. Here node 4 is having a heuristic value 70, which means the straight line distance from node 4 to node 8, the heuristic H value is 70. And these H values, hypothetical values, are assumed to be computed based on some previous experience. Now start node 1 and from 1 there are 3 nodes which are reachable, say 2, 3 and 4. At the hypothetical h values for these 2, 3, 4 referring to the heuristic table, we can see it is 80, 100 and 70 respectively, out of which node 4 is having a minimum value. So, from 1 we come to node 4, we choose this. That is, we are choosing a node that is closest to the goal node, and from 4 you can see there are 2 nodes which are reachable, one is 7 and the other one is 6. Looking at the heuristic table, we can see the values of node 6 is 20 and node 7 is 110. So, we prefer to move from 4 to 6, and from 6 we can directly go to the goal node, and this is how the best first search is performed. Next we will see the A star search algorithm. Here we will start with the starting cell, the starting node S with the cost 0. We have to expand the nodes based on the sum of the casts. 1, the cast to reach each cell from the start, that is the G value, and the heuristic estimate of the cast from that corresponding node to the goal. So, we will add 2 casts. One is from the start node to that corresponding node, and number 2 the heuristic estimate from that corresponding node to the goal. Once that is done, we will choose the node with the lowest f value, which is the sum of this G and H, and then go for an iteration of the 2 steps 2 and 3 until you find the goal or there are no more cells are left to expand. Let us see an example for this A star. Node 1 is going to be the start node and node 8 is going to be the goal node. This is the heuristics table given. Now, at node 1, let us consider the sum of the 2 casts. The first thing is from the source node to that corresponding node, and from that node to the heuristic from that node to the goal node. So, at node 1 we are summing up the 2 casts at 0 plus 120. So, from source node to reach that node is the first cast value. Here 1 itself is the source node. So, the distance is, the cast is 0 plus the heuristic value of that node is 120. So, 0 plus 120 equal to 120. Now, from node 1 we can reach nodes 2, 3 and 4. Considering node 2, from 1 if you want to reach node 2, the distance is, the cast is 45. So, 45 plus the heuristic of 2 is 80. So, 45 plus 80 is 125. Likewise, for node 3, from the source node to reach node 3, the cast is 40. So, 40 plus the heuristic value of node 3 is 100. So, 40 plus 100 is 140. Likewise, for node 4, from the source node to node 4 is 50 and the heuristic value is 70. So, 50 plus 70 is 120. Out of these 3 values, say 125, 140 and 120, the minimal one is. Now, from node 4, there are 3 nodes which are reachable. One is from 4 we can go to node 1, the same source node, node 7 and node 6. From node 4, if we want to go to node 1, the cast is 100. It is because from node 1 to reach node 4 it is 50, and from 4 again to go to node 1 it is 50. So, 50 plus 50 is 100, that is to be added to the heuristic value of node 1, which is 220, and again for node 6 node 6. To reach node 6 from the start node, it is 50 plus 75, which is 125, and the heuristic value of 6 is 20. So, 125 plus 20 is 145. Then let us compute for node 7. For node 7, from node 1 to reach 4 it is 50, from 4 to reach 7 it is 59. So, 50 plus 59 is 109, plus the heuristic value of 7 is 110. 109 plus 110, it is 219. Now, comparing the values of all the nodes, say 220, 145, 219 and 125, 140, we need to compare and check the minimal node, which is found to be node 2. Let us expand the child nodes of node 2. From node 2, we can reach 1, either 1 or 5. To compute for node 1, it is 90 plus 120, which is 210, which means from node 1 we come to node 2, then again from node 2 you go to node 1. So, 45 plus 45, it is 90, and the heuristic value of 1 is 120, which is 210. Then coming to node 5, from the start node to reach node 5, it is 45 plus 60, that is 105, plus the heuristic node of node 5 is 26. So, 105 plus 26 is 131. Now, when we compare the minimal of all, now out of the values we have found node 5 to be the optimal node. Now, let us expand that node 5. Node 5, from here we can reach node 2 and 8. Finding out the cars, they are 245 and 133 respectively. So, we have found out the optimal node, again that is the goal node, that is found to be minimal. And this is how the informed search method, that is the A star search type in the informed search method, is done. Thank you.